Okay, thank you. So thank you everyone for coming. I'm Hadrien Croubois. I'll be discussing Subgraph, then Subgraphs, and present you with a new tooling OpenZeppelin is coming up with. So stay tuned until the end. So the first thing I'd like to discuss is graph density. And this might sound like a fancy thing for a graph theory thing that some of you might have studied in university, but actually it has very concrete consequences. And the first example I'd like to present you to explain graph density is the example of Wikipedia. And when you go to Wikipedia, there are a lot of links, like a lot. There are internal links to move around inside a page, and there are links to other pages. And if you ever played WikiRace, or if you know 6 degrees of Wikipedia, you know that you can go from any web page of any other web page in Wikipedia very quickly by just clicking on links. And I think this is where the value of Wikipedia is. It's not just about the data and the content, but it's about how the data is linked. And the more links there are, the easier it is to build queries and to run from one page, one piece of data to another. And this is something we also see in the blockchain space when we go to Etherscan. I'm sure a lot of developers are using Etherscan daily. And again, just like Wikipedia, there are a lot of links. From smart contract, you can go to any transactions. You can go to any addresses. You can verify every transaction sent from an address or received by an address. And for the transaction, you can have a look at what storage slots were modified, who was involved, sometimes which token were moved. And you can go to transaction. From transaction, you can go to blocks. From blocks, you can fetch all the other transactions and so on. So it's very easy to jump between entities. And this has been very powerful to debug or to understand exploits better. And when we consider subgraphs, density is also very important. So subgraph, for those who don't already know, are the name that is given to the indexing layer in the graph ecosystem. And basically what subgraphs do is basically they index data from the blockchain and provide them in a structured way. And this is very interesting because sometimes you can just query the blockchain to read the storage, but sometimes you need more structure. You want to know the history of a loan in Maker, for example, or you want to have more data than what's simplistically queryable in the storage state. And this is where Subgraph comes in, and this is where you basically describe your application and the way your blockchain operations perform, and you can create a UI on top of that. And it's used by a lot of projects out there, so obviously it's really interesting. And there are a lot of subgraphs, but there are very different qualities of subgraphs. And so here is an example of a subgraph that I found that is featured on the Legacy Explorer, where you see that it's about contracts, about orders, and about transfers. But when you have a look at what's actually inside the different entities, you don't have any links. Here you have an address, which is just a byte. The token holders are just strings. They are not actually token holders. This is probably the address, and the IDs are probably the address. We don't know that for sure, but it's very likely. But this means that from a token contract, if we want to retrieve the top 100 holders, well, we have to read all the holders, which are a lot and are not sortable. They are just strings. So you can sort them alphabetically, but it doesn't make a lot of sense. And then you have to do one query per order and get their balance. And then you will have to filter that and try to sort it. It's a mess. So please don't build this kind of subgraphs. On the other hand, you have these subgraphs. And it's pretty similar. You see, there are ERC20 contracts, there are ERC20 balances. And if you want to have a look at the balances, you have a list of objects, and the object contains the account, which is the address, basically, and they also contain the value, both in decimal and in exact format. And so if you want to know the top 100 holders, well, it's really simple. For any contract, you can just filter the balances by value decrementally, take the first 100, and the database layer will take care of that. You don't have to do any other transaction in one single query to the database. You get everything. Also, you can read all the transfers, and if we go further into this subgraph, we know that there are events, and there are a lot of events registered, and for each event you have a transaction object, and for each transaction object you have a list of events. So just like on Etherscan, you can really get complex linking into your subgraphs. And if you go to the account object we saw previously, it's not just an address. It's a history of basically everything that's pointed to an account. So if you know that this account has a balance, you can also get the list of all the balances for all the other tokens. You can get the list of all the approvals. And you can get basically a lot of things. And I believe this is the right way to build subgraph, because this helps you to create a lot of links between your entities, and it helps you and your users build better querying systems. So basically, my guideline to build a good subgraph, and this is what you should leave the room with if you are trying to build your own subgraph, is try to have as many high-level entities as possible, like token balances, loans, if you are writing, for example, a subgraph for a maker or similar financial system, but also have low-level entities like addresses, event, transaction, and try to have as many links between these entities as possible so that you really end up with a dense graph of data that is easily queryable. One thing also is that's more technical, but when you are building a subgraph, you can listen for transitions because transactions were called. You can listen for events. You can query the blockchain to read the state of a function at a particular point. Some features are more expensive and less efficient to do. So as much as possible, please try to stick to only getting events and only rebuilding your data from events. And that also means that if you are building contracts and you think that at some point you will build a subgraph on top of that, try to think about what needs to be in the event so that it will be easy for you to build a subgraph in a second run. So those are guidelines, and it might feel difficult and abstract to use them all. But here it's what it allows you to do. This is an example where, given an ERC20 smart contract, we are able to get the first 100 balances sorted by balance, and we get the address and the value for each one of these. By getting further, we can get, for an account, the list of all the ERC20 contracts that are indexed by this subgraph, obviously, with the details of the ERC20, and we have the list of all the inbound and outbound transfer. And for each one of these, you have the transaction with the timestamp, block number, and everything. So you can almost recreate an explorer from that. And if you're going further, and if you are using OpenZeppelin contract, you can even have a look at these ERC20 contracts and say that, oh, this contract is also an access controller, so I want to get the value of the list of all the admins. Admins are basically the one with role 0. And for each of these admins, I want their balances. So very quickly, you can have a deep look into the structure of your application, who are the administrator, what powers they have, what token balances they have, and everything. And this is basically what I've did in many of my subgraphs that you can find on the Explorer. So I'm known to have been built a few subgraphs. And I try to use this design every time I build a subgraph, which might be for a specific application like POAP, or just a meta subgraph like the one I have for ERC721, which lists the entire NFT space in the mainnet blockchain. But what about you? How would you do that? Because that might sound difficult. So this is where OpenZeppelin Subgraphs comes in. And OpenZeppelin Subgraph is a new tooling that OpenZeppelin provides that you will be able to use for building your subgraphs. And the idea behind OpenZeppelin Subgraph is I want OpenZeppelin Subgraph to be to the graph protocol what OpenZeppelin contracts are to smart contracts. These are not the be-all, end-all of smart contract, but they are very effective pieces of software that you will be able to use to create smart contract, complex smart contract, and to create the corresponding subgraphs. And the idea behind OpenZeppelin Subgraph is to have modules that matches the most commonly used contracts in OpenZeppelin contract. And you can use them to be a tailor-made subgraph that is dense, that is effective for your application. So let's have a look at what we can find in OpenZeppelin Subgraph. For each module, you will find a schema of the entities. So that's what we saw previously. It's a schema of the database. This is how you will be able to query your subgraph. You have a data source template that you will be able to use so that you can very easily create your subgraph manifest to decide what you want to index. And you have the indexing logic that is written in assembly script. We also have a pre-compiled schema with all the modules enabled if you don't want to rebuild your own, because that can be a bit painful. And the subgraphs can be assembled either manually or they can be created procedurally using this toolkit that I'm also providing. It's external to OpenZeppelin, but it's working hand with OpenZeppelin Subgraph. And note that I use the advice that I provided earlier, meaning that all these modules that I'm providing only use events and as few function calls as possible, so that I try to guarantee the best possible indexing logic when creating subgraphs. So here is an example of a subgraph. And basically what we are going to do here is recreate a subgraph for the POAP token. And the POAP token has a few features in it. In particular, it's a posable contract, and it's an ERC721. And so from OpenZeppelin Subgraph, you have a list of all the modules that are available, so you can get just the ERC721 template, which is a YAML file, and the same from posable. And you have these two files with empty slots that you have to fill in, like the network, so you can put mainnet, the address, the start block, and things like that. And you will concatenate them and create a file like this, which is your subgraph manifest. And with this subgraph manifest, you can just publish it to the graph, and it will start indexing, and you will be able to query it. And the good thing is, if you do it using this schema, just like other people have done, you will have the same database language, the structure, so people will be able to query your subgraph and other subgraph transparently, which I think it's a nice feature to have. Also, what you can do, and what I encourage you to try, is use this tooling graph protocol utils, which is even more powerful, because what you can then do is just create a config.json file saying, hey, I'm on mainnet. These are 5 or 6 smart contracts I want to index. These are their start blocks. You can put 0 here, but if you put the right value, it will index even faster. And you're saying, OK, this is a knownable ERC721. This is a knownable 1155. This is an access control ERC20. This is a time lock controller, so it's time lock plus access control. And you could have as many modules as you want for every address. And then you just use this utility, so graph compiler, with this config.json. So here I call it sample.json. There is a mismatch, but you understand it. You include OpenZeppelin Subgraph. That's an NPM package, and it will produce a schema that contains only the structure you need, nothing more, and it will also export the subgraph manifest. And with these 2 files, you can just send them to the graph, either on the hosted service or on the graph decentralized network, and you will be able to start indexing. And if you're on the decentralized network, you can start curating, an indexer will catch on that, and your data will be available for everybody. So here, very quick word about OpenZeppelin, in case you don't already know us. We are a big part of this ecosystem. We do audits, but also we have a product branch. Obviously, this is part of the product branch. And this OpenZeppelin Subgraphs is part of OpenZeppelin contract, but we also have Defender and audits. So basically, whenever you are building a decentralized application, you should be able to do basically any step using our tooling at some point. And so we will help you build your smart contract, build your subgraph, obviously. We provide auditing services as well. And we have Defender, which is another product we have that will help you manage your application when it's running. You can trigger events, like have notification whenever something happens on chains. And hopefully very soon we will be able to detect events using this subgraph system that is also available. So if you're interested, let us know, because we also hire people to build amazing tools. So yeah, this is the links you want to go through. We have documentation, we have the forum, we have the NPM package. And thank you so very much. So if you have any question, I'm here.
For your ERC721 subgraph, for example, so each ERC721 contract is a separate data source in your subgraph. And what if you want to add a new ERC721 contract, for example? What's your process? Do you deploy a new version and then publish it to the network, or do you wait for multiple ERC721 to be on your subgraph to update it?
Okay, so this is a very good question, and I think it's a specificity of subgraphs, is that data sources have an address field, which is optional. And so there are 2 things. Either you can have many data sources, 1 per ERC721, or you could have 1 single entry with no address, but that's going to index the entire blockchain, so all 721s, even the ones that don't interest you. And the last option is, in addition to data sources, there is a template block. So if you wanted to, so I'm not really sure we support that, but if you wanted to take this piece of code, obviously the generating script will not generate templates, but you could reuse these pieces of code and this indexing logic for data sources, and then you will have to build your own, for example, factory indexing mechanism that will get event from the factory and instantiate new data sources. That's definitely possible to do. I'm not sure my tooling is really adequate for that, but that's a very good use case, so I will investigate that to try improve your experience with that. And yes, if you don't use the templates, if you just have like a few data sources, if you want to add a new one, you have to resynchronize the entire subgraph. This is pretty painful. That's why for cases like ERC721, I provide this meta subgraph that indexes the entire blockchain space, and at least mainnet. That way, if the only thing you want is ERC721s, and you don't care about access control, posable, and everything like that, there is this subgraph here, which does it already. So if you have ERC721 on mainnet currently, or 1155s, they're already indexed by these two subgraphs. But in some cases, people find it painful to target different subgraphs in the same application. So that's where maybe for your application, you want to build a custom design with only the data you want and nothing more.
Hey, yeah, I just wanted to add to that answer. There's a compromise that we can do, and that we did on Claros Curate, which is to have a contract that emits an event, and then whenever you just call a function, it emits an event, and then in the subgraph you can read that event to learn what's the address of the contract that you want to start tracking.
Yeah, that would use a template mechanism, and it works great, except it will start indexing at the time the event is received. So if you emit an event for a contract that already exists, any past activity will be missed. Well, I don't see any other questions, so thank you very much, and please try it out.